Today's video is going to be debunking the liar's paradox again. I know I have a video on this already, but I want to give such a clear explanation that everybody understands it. So what I want you to do is to rate my explanation. Please tell me A, how clear is my explanation, and B, how convincing is my explanation on a scale of like 1 to 10 or something. And I'd really appreciate your feedback, so if you can leave in the comments. Alright, so this is the liar's paradox. It's as simple as this. This sentence is false. That's all it is. And if you're familiar with it, you already kind of know what happens. If the sentence is false, then it becomes true. And then if it becomes true, it becomes false. And if it's false, it becomes true. And so you have this paradox, right? So I'll try to explain it a bit better here. So it makes pretty good sense. So this sentence is false is a statement. And the statement itself must either be false or true, right? Now, in the event that this sentence is a false statement, well, it says this sentence is false, and it is in fact false. So it's actually true because it's saying it's false and it is false. It's telling the truth. So it's not in fact false. It's actually true, right? Now it says this sentence is false, but it's actually a true statement and it's saying it's false. So it's a lie, right? It says this sentence is false, but it's actually true. So that's a lie, which means it's false. So now it's no longer true and it becomes false, and we're back to the same loop, right? Now it's saying this sentence is false and it's a false statement, so that is true. So it becomes true again, false again, true, false, blah, 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 blah. I want you to rate my refutation of the liar's paradox from here on. And if possible, please rate how convincing it is, okay? Because I'm curious. So first we're going to look at the light bulb paradox. And this is not, in fact, a paradox. It's just a pretty lame light bulb. It's a light bulb that flickers. We've all seen a flickering light bulb before. It's not that amazing. So the light bulb paradox is as follows. The light bulb is neither on nor off. It's a paradox. Anytime you say the light bulb is off, I say just wait a minute, now look, it's on. And anytime you say the light bulb is on, I say just wait a minute, the light bulb is off. So what's going on here? Well, you can't put the light bulb into a definite on or off category if you're looking at the light bulb over time, because the light bulb is changing from on to off, and that's okay. There's no contradiction. In order for the light bulb paradox to be a contradiction, it would have to be both on and off at the same time. All right, so that's the key point here. A changing object cannot be put in an unchanging category. That makes good sense. So on and off are both unchanging categories, right? On cannot change and off cannot change. On is on for all time, all eternity, and off is off for all eternity, right? So these are unchanging categories, and a flickering light bulb is a changing object. If the light bulb is flickering, it's clearly a changing object. So we're trying to put a changing object into an unchanging category, and that's an irrational thing to do. If I have a green apple, and the only categories I can put it into are red or blue, it's an invalid problem. You can't classify a green apple as red or blue. There's no paradox. You simply need to have appropriate categories to classify something. Okay, so is this sentence is false like the flickering light bulb? Is it a changing object? The answer is yes. This is a changing object. And we are trying to put a changing object into an unchanging category. True and false are unchanging categories. and we're trying to put a changing object into an unchanging category. And you can't do that. It's just a logical error, not a paradox. At any given moment in time, it's either true or either false. It's never true and false at the same time, right? And in order for it to be a paradox, it would have to be both true and false at the same time. If we look at it over time, then it can be true and false, and there's no contradiction because over time, an object can change, and that's a property of time. Time allows for the changing of an object. Okay, so now I'm going to turn the light bulb paradox into the liar's paradox with a little modification. So I have a little computer chip here, and it's hooked up to this light bulb now. And we're going to write a computer script. So the computer script reads as follows. If light bulb is in state on, switch light bulb to off. And of course, if light bulb is in state off, switch light bulb to state on. Repeat. And I know that's not actual computer language, but an actual computer script and computer logic is pretty similar to that. Maybe some programmers can tell me how to actually program that. So what's going to happen with this computer script? Well, the light bulb is off. So in the event that it's in the off state, then it's going to turn it on. But now the light bulb is on, so the script has to turn it off. And on, off, repeat. The script is going to go on forever and ever and ever, and you basically have the liar's paradox. Now, I think the final component of the liar's paradox, in order to turn this into a liar's paradox, there's one more thing we have to do, which is to speed up the flickering. So right now, it's very easy to say whether the light bulb is on or off. We just look at it at any given moment in time, or we can look at it over time and say it's both on and off, and there's no contradiction. But what happens when we speed up the flickering so much that it's both on and off at the same time? If we speed it up so that there's no time gap whatsoever between the flickering, is it on or off? All right, so this is the light bulb paradox, and I guess I'm the inventor of it. I haven't heard this one before from anyone, so maybe I can be a paradox inventor, but it's not a real paradox. There's just a logic error. So the first thing is the light bulb can't be off because it's on. It can't be on because it's off. It can't be both because it's neither. And it can't be neither because it's both. So what is this light bulb? Is it on, off, both, or neither? And it can't be any of those options, so we've created a paradox, right? Wrong. So if we look at Aristotle, Aristotle, I think, had a good definition of time. So Aristotle called time the motion of objects. And maybe he meant this with his definition, but I would extend it to, I would kind of upgrade this definition to any change in space or matter, right? Whenever space or matter changes, whenever anything basically happens, that is an act of time in my definition. And I made a video about this before on what is time. And I think we kind of compare time by comparing how one object in space distorts to another. But anyways, let's not get into that right now. This is all we need to solve this problem. So I'll ask this question. Can a light bulb change from on to off without changing?
It seems like a very weird question. Well, there's a very simple answer, and the answer is no. Of course it can't. In order for a light bulb to change from on to off, it has to change. Since time itself is the changing and distortion of space or matter, it's therefore impossible for a light bulb to change from on to off without time. We can simply replace the word changing with time because that's what time is. So the question, this whole light bulb paradox, it's an abstraction that can't exist. It's the exact same as saying, how many sides does a four-legged triangle have? A four-legged triangle cannot exist in metaphysics, and it cannot exist in reality. It's an irrational creation. Now, I think the last defense people are going to put up for the liar's paradox is going to be the same thing as the infinitely flickering light bulb. The one we just talked about, where it flickers so fast that it's both on and off at the same time, and there's no time gap between that. This is what they're going to try to do with the liar's paradox, and I think you can still resolve it even without the usage of time. Let's say there's this hypothetical abstract world where we process logic instantly. There's no time gap between the computer evaluating whether this sentence is true or false. It's all processed instantly, right? Well, we can still describe it as an order sequence. So, for example, if this sentence was initially true, then we would just have this order sequence here, right? And you can still describe it. You can in any terms of order. You can say at any given order, it's either true or false. And over the process, over the entire sequence, over the entire order sequence, it's both true and false, and there's no contradiction because it's never true and false in the same order sequence.
All right, so how well did I explain that? Was that crystal clear? Did that make really good sense, or did that make somewhat sense, a bit confusing, or just no sense at all? And how convinced are you? Like, are you convinced with total certainty the liar's paradox is junk and not a paradox? Are you convinced with a bit of certainty, or are you not convinced much at all, right? I am pretty convinced it's total junk and 100% refuted. What do you think?